Welcome to Q&A Wire.
Welcome to the problem number 31.16. This is chapter 31, alternating current. So in this question we are given a resistance, an inductor and capacitance. They are all connected in series with across a voltage source which has voltage amplitude equals to 30 volt and angular frequency 250 radian per second. And we need to find out voltage which is applied across all these three at t equals to 20 millisecond, and the voltage across R, voltage across L, and voltage across capacitance, and then we will go to the part B. So let's do the part one by one. So we have part A. So these are the formulas here which we will use now. So first we have Xc equals to 1 over omega C. So putting omega equals to 250 and C equals to 6 microfarad. So this gives us 666.7 ohm. Now coming to the XL, which is omega L, putting the value of omega and L here. So this gives us 225 ohm. Now finding out Z. So we have all the values here. So our R is our 200 ohm, and this is our 666.7. So we have minus 225 whole square. So this gives us 484.9 ohm. So this is the impedance of the whole circuit. So we have this much amplitude voltage, or the amplitude of the voltage. So we have the current amplitude, so which is equals to V over Z. So this comes out to be 30.0 volt over 484.9 ohm. So this gives us 61.87 milliampere. So now we will go to the finding out the phase difference. So our phase difference is equals to tan phi, which is equals to XL minus XC over R. So this gives us 225 minus 666.7 over 200. So this gives us minus 2.2085. So phi is equals to minus 1.4146 radian. Now we are right into the situation to find out all the parameters. So we have VR, which is the voltage across the resistance, is equals to the VR, the amplitude of the voltage across the resistance, cos omega t. So which is equals to the volt voltage, so which is equals to the amp current amplitude times resistance, cos omega t. So we have the current is equals to our 61.87 milliampere, so which is 0.06187 times R, which is our 200 ohm, cos omega t. So putting our omega, which is 250. Now t is our 20 millisecond, which is 0.02 seconds. So we have times 0.02. So this gives us 3.51 voltage. So this is the voltage across the resistance R at t equals to 20 milliseconds. All right. Now we are into a situation to find out the VL, which is the voltage across inductance. So we have minus VL sine omega t. Why sine? Because the phase difference between the resistance and the inductor is 90 degree. So we have cos omega t plus 90. So that's why we have minus sign here. So we have now minus I xl sine omega t, which gives us 0.06187 times xl. So xl is our 225 sine omega t. So we have 250 times 0.02. So this gives us equals to 13.35 volt. So this is the voltage across the inductance. Now finding out the VC, which is equals to VC sine omega t, which is IXC sine omega t. So putting all these factors here, so this comes out to be minus 39.55 volt. So V is equals to our capital V cos omega t plus phi, which is a voltage applied. So this is our V. So we have 30 cos 250 times 0.02 minus 5, which is 1.146. So this gives us minus 22.70 volt. So we have VR plus VL plus VC equals to 3.51 plus 13.35 plus minus 39.55. So this gives us minus 22.7 volt. So we have VR plus VL plus VC equals to V. And that has to be because these are connected in series. So this is equal to the voltage drop across the each component of the circuit. So that's your answer for your part A. Now going to the part B. So we have VR equals to capital IR. So we have 0.06187 times 200. So this gives us the voltage across the resistance or the highest voltage. So we have 12.4 volt. So these are the voltage amplitude across each component. So we have VL, which is IXL, which is putting the value of I and XL. So this gives us 13.9 volt. Now putting the value of VC, so which is equals to IXC, so which is 41.2 volt. Now comparing, so we have VR plus VC plus VL, which is equals to 12.4 plus 41.2 plus 13.9, which is equals to 67.5, and this is not equals to the V because V is our 30 volt. So we have VR plus VC plus VL equals to 67.5 volt. So that's our comparison. So that's your answer for this question. Thank you for watching the video.